After looking at sorting algorithms, now we're going to look at searching algorithms, and we're going to start with a simple example, which is of linear search. So basically with linear search, it is the simplest search algorithm out there, and the idea is quite straightforward. All you need to do is you start from the first element in a list and check each one sequentially until you find the target value or you'll reach the end of the list. So the key concepts to note when you're dealing with searching algorithms. The first thing is that it works on both sorted and unsorted arrays, and the term complexity is O of n, which means that it checks for each element once, and it's useful when the data set is small or the data set is unsorted. Now, when it comes to time complexity, it has for the best case for a linear search could be O of one, and that is in a case whereby the once it starts searching on the list, the first element is the element that it was searching for. So that becomes a best case with O of one. But now average case and worst case is of n, depending on the size of the array. Sometimes and in the worst case, it could be that the element that you're looking for is at the end of the list that you're trying to search from, but the element does not exist at all. So you end up checking for each element in the list, but at the end of the day, you don't find it, or it's at the end of that list. Now, just to look to try and visualize how that would work, assuming this is the list where we're trying to search using the linear search algorithm, what we'll do is we start with the first element. So if let's say the element that we're looking for here is, let's say we're looking for three, right? So from the beginning. We check here. We realize that three. This is not three. Then we move to the next element. Looking at it, we also realize that notice that this is not three. We go ahead and continue with this process. So this process is going to continue until we reach a point where we're going to find our element. And in this case, once we get here, we find three, which is the element that we are looking for. And that is basically what linear search is. So we're going to check for each element in the array until we find the element that we're looking for. And like you've mentioned, in the worst case where we don't find our element, then that is going to also have a time complexity of O of n. Now, what we're going to do is we're going to write some simple pseudocode on how you can implement this. And afterwards, you can go ahead and implement it in a programming language of your choice. So we'll write a function here. So let's write this in white. Okay, yeah. So write a function, and let's name our function here linear search. This S needs to be in uppercase. And so when you're writing our function, the function is going to need two parameters. It's going to need the array or the list where you are searching our element, and we also need that target element that we are looking for. In our case example here, we're looking for three, so you can also give it a variable of name of target. So after getting our or rather passing in our parameters, which is the array that we need and the target element, now we need to iterate through the entire array, the entire list. We'll need a for loop here. So let's say for each element in the array that we have, we're going to check if that element is equivalent to the target or that element is the target. So we're going to use the equivalence operator. So we'll say if the element is the target, and if that is true, we'll go ahead and return the index of that element. So we're going to return the index of the element. And finally, if the target is not found, we'll just return -1. So we'll return -1, and we can just write a comment here to show what we mean. That is, we'll return this if target is not found. And this is some simple pseudocode that you can use to write now to implement this algorithm in our programming using a programming language of your choice. Now that this is a comment here. So our function is going to need the list and the target element. We iterate through our list and try to compare each element against the target until we find the target. Then we're going to return the index of that target. And if we don't find it, we'll just return a negative one, like that. And that is simply it about linear search. Just the key points here is it is simple, but it can be inefficient for large data sets. So since it has a time complexity of n, where n is the size of the list. So if the list has about 1,000, 10,000 elements, you can see that that is going to be quite inefficient in such a case. Also, basically, don't make any assumptions when it comes to the order of the elements, since it could be the list could be sorted or unsorted. So also keeping note of that. Thank you. Next, we're going to look at binary search.